Chapter 9. Pattern, Net and Symmetry.
Nature provides patterns in flowers, animals, and shapes. The secret of discovering these patterns is to look around. This is called observation. Numbers are fascinating, and so are the patterns. Let's explore some more patterns now. Patterns in square numbers. Observe the following: 1 into 1 equals to 1, 2 into 2 equals to 4, 3 into 3 equals to 9, 4 into 4 equals to 16. A number when multiplied by itself is called a square number. Geometrically, these numbers form a square as shown here. Hence, we can make a sequence of square numbers 1, 4, 9, 16, 25, 36 and so on. This sequence can be extended infinitely. We may also find some more interesting facts and patterns with the square numbers. 1 into 1 equals to 1 square equals to 1. 2 into 2 equals to 2 square equals to 4 is equal to 1 plus 3, sum of first two odd numbers. 3 into 3 equals to 3 square equals to 9, which is equal to 1 plus 3 plus 5, sum of first three odd numbers. 4 into 4 equals to 4 square, which is equal to 16, equals to 1 plus 3 plus 5 plus 7, sum of first four odd numbers. 5 into 5 equals to 5 square equals to 25 equals to 1 plus 3 plus 5 plus 7 plus 9, sum of first five odd numbers. If you observe the above pattern carefully, each square number is the sum of consecutive odd numbers. Can you guess the next step in the pattern? Patterns in triangular numbers. Observe the following shapes made by dots. Each of the given shapes is a triangle. Count the number of dots. There are 1, 3, 6, 10, 15. The numbers that form a triangle are called triangular numbers. Looking at the triangular numbers again and notice the difference between them. You can extend the pattern easily. Hence the 7th and 8th triangular number will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 equals to 28, and 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 equals to 36. In the same way, we can find 48th triangular number and so on. So now let's look at example number 1. Find the square numbers between 100 to 400. So as we know, 100 is a square of 10. So it can be written 10 multiplied by 10. And 400 is square of 20 into 20. So if we have to find the square numbers between 100 and 400, so we start from the next digit after 10, that is 11. So our next square after 10 square would be 11 multiplied by 11 equals to 121. Then the next would be 13 multiplied by 13 equals to 169. So 13 square is 169. 14 multiplied by 14 is equal to, now 15 multiplied by 15 is equal to 225 multiplied by 16. So 16 square is 256. Then 17 after 16, 17 multiplied by 17, 289. Right here, 18 multiplied by 18 is equal to, now 19 multiplied by 19. So these are the square numbers between 100 and 400. As our next square would be same 20 square, that is 400. So these are the square between 100 to 400. Nets of solid figures. In previous class we have already learned to make 4-phase, 5-phase and 6-phase cube. Here we will make the nets of a cube, a cuboid, a cylinder and a cone. Remember, a net is a 2D representation of 3D figures. Net of a cube. Take a cubical box and cut it from its edges to obtain a flat shape. You will get the net of a cube. It may look like this. It has 6 square faces that can be joined in 11 different ways to get a cube. Try it yourself. Net of a cuboid. Take an empty pack of tea leaves or any other cuboidal box, cut it along its edges to obtain a net of a cuboid. It has 6 rectangles. Here rectangles 1 and 3 are of equal size. 2 and 6 are of equal size. 4 and 5 are of equal size. Net of a cylinder. Take a rectangular piece of paper and join it edge to edge, that is AB to DC. The solid so obtained is a cylinder with 2 open ends. If we cut 2 circles of same size as in the base of cylinder, we will get net of a cylinder. So the following nets of a cylinder can be drawn. Net of a cylinder with 2 ends open as in pipe. Net of a cylinder with 1 end open. Net of a cylinder with both the ends closed. Net of a cone. Take a conical birthday cap made up of hard paper and cut it along the curved side. Spread it on the flat surface and observe the shape. It will look like as shown below. This is a net of a cone with open base. Now think of a cone that is closed from the bottom. Its net will comprise of a circle also. Try to collect various solids from your surroundings and develop their nets. So let's look at example number 1. Which of the following represents the net as shown below? So the net here is a rectangle and a rectangle with a circle. Now this net represents, first of all, this net represents a 1 and so a cylinder with one end open. From the 4 options, let's see. No, a bowl is not a cylinder, so this is not an option. A shoebox is not a cylinder, so this option is also wrong. A Coke can and an ice cube. A Coke can is a cylindrical, yes, as its shape is, it is in cylindrical shape and its one end is, so this is our right answer. And our D option was an ice cube is also not a cylindrical shape. So we can say this net represents a Coke can. Reflection and rotation. In previous class you have learned about reflection through paper folding and ink blots. Let us learn the basics again. Reflection. When we see our image in the mirror, this is an example of reflection. Reflection of an object means to produce its mirror image. Symmetry. A method to obtain the same design after some transformation. It is of 2 types. Reflection line symmetry. A figure is said to have reflection line symmetry if it can be folded to get 2 equal halves where one part is the reflection or mirror image of other. Observe the following figures carefully. Here, each of them has line symmetry and the dotted line is called the line or axis of symmetry. A figure may have one or more axes or axes of symmetry. Look at the following geometrical figures. An isosceles triangle has 1 line of symmetry, an equilateral triangle has 3 lines of symmetry, a square has 4 lines of symmetry, a circle has infinite lines of symmetry, this quadrilateral has no lines of symmetry. Rotation. In rotational symmetry, the image is rotated about a point. The point is known as center of rotation. This point can be on the figure or any other point. Rotational symmetry. When an object can be rotated about a point to get same look, it is said to have rotational symmetry. The number of times it matches itself is called the order of symmetry. You will understand it further through the given illustrations. Similarly, a flower can be rotated to match itself a number of times. This flower can be rotated to match itself 5 times, hence it has rotational symmetry of order 5. A ceiling fan has a rotational symmetry of order 3. Few more examples of rotational symmetry are figures order of symmetry of the respective figures. Now try to find order of symmetry of a square, rectangle, triangle, etc. Smart tip. A figure may have both the reflection and rotational symmetry. Symmetry can be found in nature, architecture, art, etc. Try to find symmetrical objects in your surroundings. Can you draw axes or axes of symmetry in the above figures? Symmetry in 3D shapes. Can solids be symmetrical? Let's find out. Take a bowl and cut it into 2 equal halves. Is it possible? The answer is yes. It can be done as shown above. You will get exactly 2 equal halves, so they are symmetrical. This is called plane of symmetry. Let us try to find the planes of symmetry in other solids: cylinder, cone, cube, cuboid, and the planes of symmetry of such figures.